In this lecture, I'm going to explain graphical method to solve a game. So there are two types of games in which one player has only two strategies and other has more than two strategies. Okay, so those games are 2 by n game and m by 2 game. So 2 by n game and m by 2 game. That means here in this case, player A has only two strategies and player B has more than two strategies. In this case, player B has only two strategies and player A has more than two strategies. Okay, so these type of games can be solved by using graphical method. Okay, so in 2 by n game, player A has only two strategies and player B has more than two strategies. In M by 2 game, player B has only two strategies and player A has more than two strategies. Okay, right. First, algorithm for 2 by n game. That means player A has only two strategies. First step, reduce the size of payoff matrix up to 2 by 3 by applying dominance property if possible. Okay, so we can reduce some columns. So you are not able to reduce rows. It is possible to reduce size of the game. That is, it is possible to eliminate some redundant columns by using dominance principally. So you can reduce the size of the game up to 2 by 3. Okay, right. Once the size of the game reduced, then observe here, player A has only two strategies. Our aim is to find probability of selection of strategies. Okay, so we can choose the probability of selection of the strategies of player A. Okay, so let X be the probability of selection of first strategy by player A. Since there are only two strategies, the probability of selection of one strategy is X. Then what about the probability of selection of other strategy? Total probability minus this probability. That is, total probability is 1. So 1 minus X be the probability of selection of second strategy by player A. Okay, so X is probability of selection of first strategy, then 1 minus X is probability of selection of second strategy. Once we know the probabilities, we can calculate the expected gain for player A. Okay, so derive the expected gain function of player A with respect to each strategy of player B. Okay, find the gain values when X equals 0 and X equals 1. When X equals 0, that means probability of selection of first strategy is 0. That means player A selects second strategy with the probability 1. In that case, what is gain? Okay, so we calculate the gain values when X equals 0 and X equals 1. Then plot the gain functions on a graph by keeping X on x-axis and gain values on y-axis. Okay, so keeping X on x-axis and gains on y-axis. Since player A is max-min player, identify the highest intersection point in the lower boundary of the graph. Okay, so after drawing the graph, take the lower boundary of the region. In that lower boundary, identify the highest level intersection point. So that point is max-min player. That point is max-min point. So this point is max-min point. If there are only two lines passing through this point, then form a 2 by 2 payoff matrix from the original matrix by retaining only the columns corresponding to those two lines. Suppose there are only two lines passing through that max-min point, then consider the resulting 2 by 2 payoff matrix from the original matrix by retaining only the columns corresponding to those two lines. Suppose there are more than two lines passing through this point. This would imply that there are multiple optimal mixed strategies for player B. Okay, in that case, we choose two lines having opposite signs for their slopes. Any two lines having opposite signs for their slopes will define an alternative optimum for player B. Okay. Solve the resulting 2 by 2 game as usual. So this is the algorithm to solve a 2 by n game using graphical method. So let us clear understanding by doing an example. Solve the following game by graphical method. This is the payoff matrix. Player A has two strategies, A1 and A2. Player B has four strategies, B1, B2, B3, B4. These are the corresponding payoffs. Okay. Since player B has four strategies, so if it is possible, we can eliminate one column. Okay. So apply dominance principle for columns. So reduce size of the matrix if possible by dominance principle up to 2 by 3. Compare first two columns. First compare column 1 and column 2. Compare column 1 and column 2. First element 2 equal to second element 4, 3. So 4 greater than or equal to 3. That means we can consider 2 equal to as 2 greater than or equal to. Here 4 greater than or equal to 3. So we have same inequality. So that means column 1 and column 2 are comparable. Column 1 is greater than or equal to column 2. So column means player B. Player B is minimax player. That means he tries to select the strategy with low payoffs. That means in this, the player B always try to select second strategy. That means he can ignore first strategy. That means we can remove column 1. So delete column 1. Okay. So we have three columns. So it is not possible to reduce still the size of the game since we reached to 2 by 3 size. Okay. Now we apply the graphical method to the resulting table. Okay. So here, since player A has only two strategies, we can take probability of selection of these two strategies. So let X be the probability of selection of strategy 1 by player A. Then 1 minus X be the probability of selection of strategy 2 by player A. So it is clear by total by the property of probability. So based on these probabilities, we can find expected gain function for player A with respect to each strategy of player B. Okay, so we have tabular formula. First column, the expected gain functions of player A with respect to each strategy of player B and gain values at x equals 0 and x equal to 1 are as follows. Tabular form. First column, strategy of B. Second column, gain function of A. Third column, gain values at x equals 0 and x equal 1. What are strategies of player B? B2, B3, B4. Since first strategy is eliminated, so we have only three strategies for player B, B2, B3, B4. Okay. So corresponding to second strategy of player B, what is expected gain function of player A? Since selection of strategy of first selection of probability of okay, right, sorry. So the probability of selection of first strategy by player A is X and that of second strategy is 1 minus X. So then the expected gain function corresponding to second strategy of player B is just multiply with probabilities, the payoffs. So X into 2, 2X plus 3 into 1 minus X. So here 2 into X plus 3 into 1 minus X. That is 2X plus 3 minus 3X. That is minus X plus 3. So this is gain function corresponding to second strategy of player B. Okay. Next, calculate gain values at x0. Substitute here x0. So minus 0 plus 3, 3. Next, gain value at x equal to 1. Substitute here x equal to 1. 3 minus 1, 2. This is gain value at x equal to 1, 2. Okay. So this is expected gain function corresponding to second strategy of player B and gain values at x equals 0 and x equal 1. Similarly, calculate expected gain function corresponding to third strategy of player B. Okay. So x into 3 plus 1 minus x into 2. That is 3 into x plus 2 into 1 minus x. That is 3x plus 2 minus 2x, that is x plus 2. When x equals 0, gain value 0 plus 2, 2. When x is 1, gain value 1 plus 2, 3. Okay. Similarly, with respect to fourth strategy of player B, expected gain minus 2 into x plus 6 into 1 minus x. So minus 2 into x plus 6 into 1 minus x. That is minus 2x plus 6 minus 6x. So minus 8x plus 6. Gain values at x equals 0. Substitute here x 0, 0 plus 6, 6. Then gain value at x equal to 1. Substitute x equal to 1 here. Minus 8 plus 6, minus 2. So these are gain values. Okay. Now we draw these three functions on a graph using these gain values. Okay. So draw the gain functions on graph by taking x on x-axis and gain values on y-axis. Okay. So draw y-axis. This is y-axis. This is x-axis. So use scale and pencil to get accuracy. Since we have taken x on x-axis, x is probability of selection. So x values always lie between 0 and 1. So here the structure of the graph is different from regular graph. So we draw the graph between x equals 0 and x equal to 1 lines only. Since x is probability, it lies between 0 and 1. So we draw the graph between x equals 0 and x equal to 1 lines. X equals 0 means y-axis. X equal to 1 line means take here. This is x equal to 1 line. Okay. So this is x equals 0 line and this is x equal to 1 line. So we draw the graph between these two lines only. That means we draw the expected gain functions between these two lines. Okay. So identify the points. Take 1 centimeter equal 1 unit on both lines, on x equals 0 line as well as on x equal to 1 line. Okay. So by observing the gain values, the range is minus 2 to 6 for x0 and the range is same range minus 2 to 6. Observe here, for x0 the range is maximum 6. For x1 the range is minus 2 to 3. So overall the range is minus 2 to 6. Okay. So these are the points. So use scale and pencil and identify the points at equal distance to get accuracy. Okay, right. First I draw the line corresponding to second strategy B2. This is minus x plus 3. Okay. So when x equals 0, what is gain? 3. Okay, that is 0 comma 3 point. 0 comma 3 means on x equals 0, 3, this point. This is. Okay. This is 0 comma 3. Next, at x equal to 1, gain is 2. That means 1 comma 2. That is, this is x equal to 1 line and this is 2. So this is 1 comma 2. Okay. So join these 2 points. Join these 2 points. Okay. So this is the line corresponding to second strategy of player P. Okay. Or this is the line corresponding to gain function of A with respect to second strategy of player B. So this is line corresponding to B2. Okay. Right. Next, draw this line corresponding to B3. For x equals 0, gain is 2. That is 0 comma 2. X0. This is 0 comma 2. And for x equal to 1, gain is 3. That is 1 comma 3. This is 1 comma 3. This point. Okay. So join these 2 points. So this is the line corresponding to third strategy of player B. That is B3. Or gain function of A corresponding to third strategy of player B. Okay. Right. So solve these 2 lines, B2 and B3. So let first B2 equation is y equal to minus x plus 3. and B3 equation is y equal x plus t, x plus 2. Okay, so solve these two equations to get this intersection point. So to get this intersection point, okay, solve these two equations. Just add 2y equal 5, y equal 5 by 2. Substitute here, y equal 5 by 2 minus 2, x equal 1 by 2. So this is the intersection point. Okay, next, write, draw fourth line, that is B4, where x equals 0, gain is 6, that is 0 comma 6, this point. Okay, so before drawing the line, solve B3 and B4. So to observe the fourth line, whether that line corresponding to B4 passes through this intersection point or not. To check that, solve B3 and B4 also. B3, let y equal x plus 2, B4, y equal to minus 8x plus 6. Solve these two. Just to subtract, y gets cancelled. By subtracting, y gets cancelled. X minus or minus 8x, 9x minus 3 equals 0, so minus 4, x equal 4 by 9. Substitute here, you get y equal to 22 by 9. Okay, so this point is different from this point. So B4 does not pass through this point. Okay, right? So the points on B4 are 0, 6. Okay, so this point, next 1 minus 2, for x equal to 1 minus 2, this point. Okay, so join these 2 points. Join these 2 points. So observe here, this line is not passing through this intersection point. Okay, since we are drawing a rough graph, we can observe whether all lines intersect at same point or not by solving these equations. Okay, so if you use scale and pencil and mark points at equal distance, so you get some accurate graph. Okay, so these are the lines corresponding to these 3 strategies of player B. Okay, right. Since player A has only 2 strategies, we are solving the properties of player A. Since player A is maximin player, so maxi means highest level, min means lower boundary. What is lower boundary of this region? So this graph divides the region into 2 parts. This is one part and this is another part. So this is the lower and this is upper region. Since player A is maximin player, that means maxi means highest level, minimum means lower boundary. Okay, so in this lower region, for this lower region, boundary is this one, this part. This is lower region boundary. In this lower region boundary, we have intersection points. This is this one intersection point, this one point, and this one point. Among these 3 intersection points, what is highest level intersection point is this one. This is highest level intersection point. That is maximin point. Okay, right. So this shaded region is lower region. For that lower region, this is the boundary. This is the boundary. In this boundary, you have intersection point. This is one intersection point, and this is one intersection point, and this is one intersection point. Among these 3, this is the highest level intersection point. Okay, so this is the highest level intersection point. So let the intersection points P, Q, R. Okay, the shaded part is the lower region of the graph. So highest level intersection point is Q, which is intersection of lines B3 and B4. Okay, so this point is intersection of this line, that is B4, and this is this point B3. Okay, so there are only two lines passing through this intersection point. So consider the resulting 2 by 2 matrix from original matrix by taking third and fourth column. Since this intersection point, through this intersection point, two lines are passing, that is B4 and B3, B4 and B3. Okay, we consider third column and fourth column from original matrix. Okay, so the resulting 2 by 2 payoff matrix is, this is original matrix, you take only B3 and B4. You take only these two columns. So this is the resulting 2 by 2 matrix. That means second and first strategies are eliminated for player B. Okay, so player B has only two options, B3 and B4. So this is resulting 2 by 2 matrix. Solve this matrix as usual. So write first row difference, 3 minus of minus 2, 3 plus 2, 5. Write it opposite to second row. Second row difference, 2 minus 6 minus 4. Take absolute value, 4. Right here, opposite to row 1. Next, first column difference, 3 minus 2, 1. Opposite to second column. Second column difference, minus 2 minus 6 minus 8. Take absolute value, 8. Opposite to first row. Then probabilities of selection of strategies by player A is P1. P1 is opposite value, 4 by 4 plus 5. That is 4 by 9. Next, P2. So opposite value, 5. P2 equal 5 by 5 plus 4. That is 5 by 9. So therefore, A of P1 comma P2 equal 4 by 9 and 5 by 9. So these are the probabilities of selection of strategies by player A. Next, for player B, probabilities of selection of strategies by player B is, player B has only two options, that is third option and fourth option, that is third strategy and fourth strategy. Okay, so Q3 equal, for this opposite value, 8 by sum of these two values. So this opposite value, 8 by sum of these two values, 8 plus 1. So 8 by 9. And for fourth strategy, Q4, opposite value, 1 by 8 plus 1, that is 1 by 9. And Q1, Q2 are 0, since those are eliminated. So therefore, all probabilities of P of B are B of Q1, Q2, Q3, Q4 equal Q1 0, Q2 0, Q3 8 by 9, Q4 1 by 9. So these are probabilities of selection of strategies by player B. Next, value of the game. V is right, calculate with respect to first column, 3 into 4 plus 2 into 5 by 4 plus 5. Okay, with respect to first column, 3 into 4 plus 2 into 5 by sum of these two values. So 12 plus 10, 22 by 9. So this is value of the game. Okay, so this is the way to solve a 2 by n game using graphical method.